Okay, time to get started. Welcome to how Kubernetes optimization can combat climate change. Glad to see actually so many people here. And I say so many because I have to say that I speak a lot at conferences, and sustainability topics, they don't always get the biggest crowd, so I'm always super happy to see this many people interested in this topic. Always love it so much. Hi, I'm Talvasto, and I work in product marketing. I'm also a CNCF ambassador as well as an Azure MVP, which essentially just means that I love all things cloud, and I'm super passionate about these things as well, and I do a lot of these community things and whatnot. I speak a lot of conferences, and I'm also a Kubernetes and CNCF NDC co-organizer for Finland for since 2017, so over 5 years now. I also coach early stage startups, and I'm also the co-host of Cloud Gossip podcast. In addition to these things, I am in the KubeCon program committee. I host a weekly cloud native live show for CNCF as well that you can catch on Wednesday. So a lot of these kind of things in general. I'm very happy to be here talking about one other passion of mine, which is obviously sustainability and these topics as well. Now, I said that I speak quite a lot of conferences, and this topic, particularly sustainability and green software and all of these topics, are very interesting currently. I said that the crowds aren't always big, but the topics are constantly changing. Everything is evolving. I did the same session technically a while ago in NDC Sydney, so that was about 2 months ago or so. And I have to say, when I was refreshing everything for this slide deck, essentially I could have taken everything that I did then and just redone everything with the new information. That the scene has moved on so much because everything is updating so fast, because the green software sustainability software space is relatively new, so it's getting a lot of the kind of early work done currently. So everything is getting updated very fast as far as like recommendations. Well, the basic recommendations don't change, but all of the kind of formats, the ways, and these kind of things constantly change. So that's essentially what I have to say, kind of the speciality of what's happening currently in the kind of sustainable software space. So what you will learn today, I'm hoping that you will learn like where to find the information, because there's a lot of things that I can say, oh, there's a project going on there. They're not quite ready, but when it's ready in, let's say, a month or two, it's gonna be like the best place for you to get the information from. So a lot of these kind of resources are either just being built or are going to be built. For example, the first ever working group by CNCF, the sustainability working group, just did their survey into these topics, so sustainability and Kubernetes. That just finished. They're kind of progressing the information, and they're about to release them by next KubeCon, so EU, so in a month or two. And Green Software Foundation as well is doing, or just finished a survey that finished on the last day of last year. So again, there was the first surveys into this space done, no results yet, so unfortunately can't talk about them. But what I can give you is a snapshot into what's happening, or what has been happening in this space. And if you're interested, you can then keep up with the latest and the greatest on your own as well, because it is constantly updating. But yeah, that's the agenda for today. We have essentially an introduction to this topic, so even if you are not familiar with green software at all, after this session you should have all the kind of basics hopefully handled, and you're gonna kind of get set on your journey. And then obviously we're gonna connect that all to Kubernetes and microservices in general, so that we can all kind of focus on that side. So there's kind of two sides to the session. There's the green software in general, which applies to Kubernetes as well, and then the more Kubernetes specific portions of this session as well. That's the kind of more decisive agenda here. So we have the introduction that's ongoing right now. Then we have the principles of green software, and then we have the principles in practice in microservices context, and then we have some open source projects that you can actually get started with on your own, even right now, and then the resources. And as kind of already there hinted before, the resources in this session are gonna be, I don't want to say extensive, all sessions usually have a good amount of resources, but there's a lot that you can kind of follow up on later with, for sure. And I'll share all the links in the end then for that. But yeah, But let's get started. So, I think people in general are starting to care or care even about sustainability more and more. And it is very much a standard to think about, okay, in our everyday life, do we recycle, do we buy secondhand, how much do we consume, and so forth. But I think quite often an overlooked topic is what about our working life? And I love the fact that people are really opening up to this realization. Because, for example, if you are a developer or work in IT in general, the impact that you have at work to these matters might be 10 times larger, so much greater than the impact of action that you can take at home. It doesn't make the action that you do at home any less important, but the difference between, like having a TV on compared to having 100 servers running, the scale is completely different. Like, it's not even comparable in that sense. So there's obviously a lot that one can think about as far as like our professional lives go as well. And the information that not like a lot of people usually think about is that really the technology industry consistently adds quite a good percentage of the emissions on every year. And for example, the airline industry is talked about a lot. How much do you fly? Do you fly, for what reason and so forth? But then the software industry actually pollutes exactly the same amount. And I actually find this very interesting. I've just had recently a discussion with a senior engineering manager on AI space. He had built multiple AI teams, and I told him, I'm speaking about sustainability and computing. And there's like, what do these things have together? Like, what do you unite them? How are they connected? And I was like, well, if you do your AI things, that uses quite a lot of computing power, and that obviously uses energy, and therefore we end up in the situation that it is one of the biggest polluters out there. And then I could see the light bulb going on in his head, and it's like, oh. And he was actually a very sustainability focused guy on his private life, but he had never kind of connected the dots in his working life, which I think is a kind of relatively common situation, I think, sometimes to people. But as you can see in the example here, AI, machine learning are these things, they require more and more compute power. So the world is just upping our consumption of cloud resources to begin with. So the issue, or I guess as a passionate cloud person, the positive issue of these services expanding and being more available also then creates that issue that we are then combating with the sustainability angle of it. So you have to kind of balance there out that. But it's definitely going to be just increasing rather than decreasing the consumption that we have. And really, I think hopefully everyone has heard about this small thing called climate change that is kind of going to experience reversible changes if these things aren't mattered. In addition to obviously, also if we build our services in a sustainable way that are not harmful to the environment, it obviously benefits usually companies in a lot of different ways by being more cost effective and all of these kind of things as well. As well as pollution obviously adds different issues in addition to climate change from quality of air and so forth. So it's not completely zero-sum game there. Okay. So the topic was kind of okay, Kubernetes and how does it connect with climate change? Well, Kubernetes is particularly nowadays, so this is I think from 1 year or 2 years old. Kubernetes, CNCF does the whole Kubernetes does a survey every year into how is Kubernetes adoption going, how technologies are being adopted, and even in that one or a few years ago, 96% of organizations are either using or evaluating Kubernetes, and obviously that is just getting stronger and stronger constantly. So obviously Kubernetes is widely used. The technology industry has a lot of energy consumption happening, so we can kind of connect the dots there. But if we do Kubernetes optimization really well, we can actually tackle the other issue as well, likely there. And now there's a lot of configuration best practices. This is from the Kubernetes, docs for configuration best practices. So there's a lot of things that you can do just with this. So even if you just kind of figure out how to do best practices Kubernetes deployment from the start, or that would be the bare minimum, you're already kind of on a good roll, and there's a lot of content around that, of course, but obviously more specific green software, sustainability software specific examples are the best and the kind of hit that give you the most direct answer, so to say. But obviously there's like a lot of tips in general around this space. But then a bit about the principles of green software. How many here has heard about the Green Software Foundation before? Oh, well, one hand goes in. That's really nice, actually. Like last time I asked this, like over half of the people raised their hand and yeah, sure, they're experts. But I'm like, okay, well, then I'm gonna be running through these things, and everyone maybe had heard them, but that's absolutely really great. You all maybe are new to the topic, so then we all do a bit more learning, which is awesome. More value, I guess, out of this session. So Green Software Foundation is a relatively new foundation, so it's I think 1 to 2 years old, 3 years maybe. Time is relative, I think, particularly with the COVID and everything. I don't know which year it is anymore and so forth, but it is new in terms of Kubernetes being 6 years whatnot old and whatnot, so it's quite a new thing. And they're still building some of the building blocks, the basics there. So it is a non-profit foundation. There's a lot of different big companies supporting it. So there's everything from Microsoft to Red Hat to IBM, and everyone essentially is kind of playing there together. And it's a software that is building a trusted ecosystem of people, standards, tooling, and best practices for green software. So it is not a Kubernetes-specific foundation, but they do focus a lot on the cloud as well. So a lot of those examples apply to Kubernetes as well. So it's a very, very nice foundation to follow. And there's a lot of things happening there. Like when I spoke about this 2 months ago in NDC Sydney, I said things like, oh, they're doing this project, and today I can actually show you those projects that they have just launched, and more is coming constantly, so the space is constantly kind of changing. So they have started their work like a few years ago from thinking about, okay, we have this, people care about sustainability, people want to do green software and sustainable software development. But before we can actually just jump into the best practices or the how-tos and whatnot, we actually have to agree on what is green software, how do you define it, how do you measure it, what do you even measure for, like how do you quantify these things where, very interestingly people can kind of be like, oh, that's clean or bad energy or something, but how do you actually define these things? So there's principles of green software that they have developed, which is kind of the building block and the foundation for a lot of the work there. Just out of interest, has anyone heard about the principles of green software without hearing about the foundation? No, okay, well listen. Sometimes these things might go like people hear about the work before the foundation, but yeah. So the first stop is carbon. It's the first principle to follow essentially. So build applications that are carbon efficient. So no matter what we do, essentially, we will always emit carbon through our activities. So the goal is to get each gram of carbon we emit into the atmosphere to make sure that we extract the most value from it. So essentially, you cannot be like not emitting any carbon, but you can get the most value per carbon that you produce, essentially. So that's the point here. And also then it's really being about building carbon efficient applications that add the same value to a user but emit less carbon. So we are not talking here about like making services worse. We're not talking about building worse services. We're talking about building the same value to the users, but emitting less carbon while we are providing that same value or even greater value, for example. And in the same way, electricity, so build applications that are energy efficient. So the same applies here as the carbon. So just emit less energy, use less energy. Then there's a bit of a different one, which is carbon intensity. So you consume electricity with the lowest carbon intensity. So it is the intensity of electricity is a measure of how much carbon emissions produced per kilowatt hour of electricity consumed. So then we're just talking in relative terms and these kind of things as well. No need to worry about the exact definitions here. There's not going to be a quiz. I'm not going to be asking you about this stuff. No need to remember anything. But I think it's important to know that, these are the ways these things are measured, and this is the kind of the language that people speak together when they talk about these things. So there's embodied carbon as well, so building applications that are hardware efficient. So embedded carbon, for example, would be, embedded carbon, which is the other word, is the amount of carbon pollution emitted during the creation and disposal of a device. So for example, this laptop that I'm using here, so it's not just the cloud computing resources that I'm using. It would be the servers within that data center, for example. So we can't just think about the electricity that goes into the machine when we're using it, but okay, what were the natural resources that we used to build those machines that we're working with. Then we have energy proportionality. That's the hardest word, I think, for me to honestly to say. But yeah, so it's about maximizing the energy efficiency of hardware. So then again, as you can see, there's kind of like a theme here. So you have a unit that measures something, and then it's the maximizing the energy efficiency out of it and so forth. So are you essentially using your resources well then, whatever output you're doing? So then it's networking, so it's reducing the amount of data and distance it must travel across the network, because the amount of carbon emitted to send data depends on many factors, from the size of the data to distance the data travels. And then we have demand shaping, which is building carbon-aware applications. So it's the strategy of moving compute to regions or times when the carbon intensity is less. I have a bit more about that later. And then we have measurement and optimization. So you can focus on step-by-step optimizations that increase the overall carbon efficiency. There's no like magic bullet that you will just flip a switch on and then you know, oh, everything will be perfect and sustainable and green. No, it's really about making incremental changes and optimizations, and then you're kind of getting closer to the end goal there. So these are essentially the principles that if you just know this list, you know quite a good portion of these things. Yeah.
When you're existing application, called user or conditions, it's quite straightforward to measure. Measure what your output essentially is now. You will see how your progress. If you start creating new applications, new construction, is there behind these principles some measures to find efficiency? Because otherwise, when the first application will be full open to the implementation of what is efficient.
Yeah, so essentially like when you're optimizing existing applications, then you're like, just optimizing and you're reducing footprint, but if you're creating a new thing, then is the creation of the new thing already bad in itself, or what do you mean by that?
Well, when you create something new, how do you find efficient application? If you try to follow these principles, how do you know that new application is efficient, are metrics?
Yeah, there is getting to it too. Yeah, no worries. Yeah, but good question. That's exactly where kind of the mind goes. Exactly. It's like, okay, how do we measure it? Like, what are the measurements, and how do we then measure it, and how do we then optimize from there? So perfect. But if that was, I have it in I think a few slides. But then, if that was too many things, essentially the most important ones are carbon efficiency, energy efficiency, hardware efficiency, and carbon awareness. So with those building blocks, you can start. I think it's in a few slides, so then we're gonna get to that portion there. Before that, we have energy, which is at the heart of everything. Probably you heard from some of the examples that I gave already there. So what electricity, for example, runs in your grid, that impacts a lot of the greenness of your application, for example, because there's a huge difference between, for example, coal energy or wind energy. So like what comes through your block to your computer. So there's a lot of regional differences. So Nordics have a lot of renewable energy. France is heavily nuclear based. So these are quite green energy forms. And then, for example, Australia has a lot more coal and whatnot. So it depends a lot on the location, on how green the energy is that you're using. And there's a lot of differences between even locally, like which data center do you use within a country, for example. There's, for example, looks into it that, for example, if you use a certain data center in UK, it's better than one data center in Nordics, for example. So you can kind of choose your location from there. So that is essentially location shifting. So because the intensity of electricity differs by location, so then it means that when you switch the location of where your application is running, then you're switching the output of it and everything like this. And I think the good example of this is that Google did an experiment into this. they did a carbon-aware data center experimentation, and they did a shift between locally, just small locations, so not even like from UK to Nordics, just like locally within one country or whatnot. So latency, for example, wasn't affected so much and whatnot, and they were able to cut 1% of their emissions by just that, and no, essentially, kind of again, no worse solution for users or so. So, and 1% sounds like a small amount, 1%, but when you're thinking about the scale of Google, that's obviously absolutely humongous numbers we're talking about there. So Green Software Foundation has this image on different things that has the different locations here. I've been trying to find like a good image of like the whole globe and like where is good energy and bad energy. But obviously the energy grid is much more complicated than that, so I cannot find it, but this is the closest that we have. But essentially you can see that there's a lot of difference. So you see the slider there with green to like black, unclean energy and whatnot. So there's a lot of differences around. Then another thing is time shifting. So we have, for example, the time of when you're using the energy and electricity differs a lot and has a huge impact on your emissions as well. So here is the California hourly electric load versus load about from the solar wind. So essentially, when the sun sets, for example, that's when people start, usually watching TV with their family and so forth. So actually, the energy use peaks, but also solar power is not available then. So it's actually very interesting that when people are in their everyday lives, essentially consuming the most energy, the energy is also the least green that it is in some ways. Yeah. Yeah. It is. It's for sure. That's definitely not a good thing to chop down the rainforest. No, in no way. But it's never exactly like there's no easy solutions. And I think probably the region there likely is not the rainforest. It's probably a data center nearby that uses renewable energy. Because, for example, yeah. True. It's definitely not as simple. Yeah. Yeah. Completely agree. Very, very difficult. And also the location varies. And for example, you need a lot less cooling in the Arctic regions than in the Nordic regions. So there's like so many different variables to go into here for sure. But yeah, time shifting. So if you are able to, it's always good to run software when the carbon intensity is low. And obviously this is not possible for everything. Or for example, batch jobs or something, training in machine learning or something. It doesn't really matter, or do we do it today at like 6 p.m. or do we do it during the night when the energy consumption is low to begin with? So that reduces the carbon need, by a lot. And just by switching it by an hour, that already really impacts positively there. And for example, a good example of this is Windows is nowadays carbon aware, more or less. So it gives you, it updates the machine on carbon when carbon intensity is low, rather than randomly, at any given time, if possible. So there's like all of these kind of things that you can do. Then we have demand shaping as well. So here's an example that I can actually show live as well. So this is an example that's not possible for all applications, but this is a nice example of it. So this is a magazine called Branch, and they have an actually demand-shaped website. So you see here the grid intensity view. If it's high, then it looks like this, or we can actually put it live, so then it shows it live, and this is then always optimized to what's happening in the grid. And then if we put it on low, the grid intensity is low. So now you can see, there's images, there's more colors. So we're using more computing power to have this website up and running. And if we put it at high, then the images go away. So again, we're using less computing power there. And then if we put moderate, there is images, but they are in grayscale. And now obviously this is not possible for everyone, because for this magazine, for example, that this image is in grayscale, it doesn't really impact the user experience too much. But this is a good example, I think, of demand shaping of, when do we need images and when do we don't need images, for example. Then we have increasing utilization. So this is one of the good principles around this topic as well. So if you're using hardware, so instead of using multiple resources with not optimal utilization, so you see here on the right, you have three resources in use and you're using 30% of all of them. That's a lot less worse for the environment than using 100% of one resource. So all of these kind of things in this tricky area where Kubernetes in particular can be very helpful if managed correctly. And then actually we get to your question, which is the software carbon intensity measure, so SCI. So this is a new a project from Green Software Foundation. So it defines a methodology for calculating the rate of carbon emissions for a software system. And there's a bit more info there. And this was just newly released, I think in February, like December or so, essentially. Very fresh. So when I was doing the session in NDC Sydney, I said, oh, it's not out yet. We have to wait. But here it is. It's available. I'm not going to do like a super deep dive into it. But if you are interested, there is a deep dive into it in GitHub, and I can actually maybe just show that as well quickly, because I have the page open like here. Green Software Foundation, so then you go to projects, and then you have the software carbon intensity specification, which takes you to GitHub. And in here you see a lot of different things. So you have the project scope and whatnot, and then you can find, and there's like a really cool image that they have quite often that they use. The latest publication version is available here. So you can find, there's a lot of info here. So the basic calculation is, for example, here, or this, I think this can be expanded to this one. So this is the one that they are currently essentially using, but it is constantly being reiterated on. There's a lot of like different information here on how this is calculated. And I'm gonna go into the practice, so like the principles in practice and more like exact recommendations, well, how to do these things in practice. But I do find that I'm gonna now give a teaser. I was supposed to show this after it, but if we are in green software projects, if we are green software patterns, so these are some of the things that I'm going to be running through soon, a modified version of this. So catalog, if we put cloud, for example, and then we took the first one. In here we can see, for example, if you implement this pattern, we see here that an example of how does it impact the SCI. So, for example, if you implement this pattern, it will reduce the distance packet travels, which is then going to reduce the E, which is the energy there. So this is the kind of work the Green Software Foundation does, for example, is that we have the measurement and also the different patterns where we can actually impact that measurement, so which is already kind of also spelled out there. Yeah, so if you want, you can always go find that out there. And I think there are, as I said, constantly reiterating on it as well. And by the way, the Green Software Foundation is essentially an open source foundation in the way that they are doing all of this in the open, so anyone can just join in and chime in and start contributing to the work as well. And they are not even just open to feedback, they actively want your feedback. So if you look at this and you're like, that maybe makes no sense, or like, whoa, my organization does things this way, or I have this recommendation, or I found this, you can just send them emails, join the Slack and whatnot, and then the reiteration of that work will be continued. And I think I've seen a few versions of this floating around. There was the kind of simple one and then the extended one as well. So it's constantly being worked on. But yeah, then we have the principles in practice. This was essentially one of the few of these patterns that we saw there. So this is a microservices example. And this is kind of high level. You have to optimize network traffic, you have to increase your compute utilization, reduce your number of microservices, optimize your database, understand your latency limitations, and so forth. So, sounds easy, yeah? Just get on doing it and you're done essentially. Not that simple. I do have a bit more information on all of these points, but as said before, it's essentially like a countless list of small optimizations that you're essentially doing to end in a great result. But also, I do want to stress that if all of this sounds to be like, oh, there's so many things, oh, there's this and that, and so many things you need to do, obviously anything that you do, even one step, is going to bring your software to a better place in a way. So there's no need to kind of be perfect on the first go, for example. But yeah, so optimizing your network traffic, for example, can mean things like reducing the amount of traffic your architecture creates, as well as the distance each request and response travels. It can be something as caching headers, so considering using caching headers, for example, considering using CDN, so content delivery network, so distributing your application static assets closer to the source of a request. So this distribution of assets then reduces the distance all requests for static assets has to travel over the network, for example. If possible, reducing the size and optimizing your bundles and static assets as well. And then using compression and decompression for data, because this takes usually less overall energy. And obviously usually is an operating word there because I don't know exactly what your environment, for example, looks like. So these are not like, do this and it's going to be perfect, but usually this is what happens. So increasing your computer utilization, so updating workload, distribution and compute resources, so use less resources at higher utilization. So this is exactly the image that I showed before. So we knew this one already. Smaller virtual machines as well. So as said again, using the resources that you have as a whole, because smaller ones use less energy than larger virtual machines. And evaluating migrating your workload to platform as a service, for example, because platform as a service solutions are sized usually appropriately for their workflow, so there is not that kind of idle resources around hanging there. So, for example, if you were to build new applications, starting from platform as a service application building blocks could be probably a good thing from the get-go. Using autoscaling or burst capabilities, I have a demo on autoscaling coming up soon. So it means that you allow to increase and decrease to your resources and your needs. And then using, if you have many logical layers in a physical tier, considering increasing your physical tiers and reorganizing where your logical layers land for more flexibility to scale your logical layers there. Then we have reduced the number of microservices. So just using a microservice architecture to begin with, because it usually helps limit network congestion, latency, and overall complexity. And combining services that are logically or physically where similar scale points, for example, exist to reduce the footprint of overall architecture. And if two or more microservices are highly coupled, consider co-locating to reduce network congestion and latency as well. Then use regions with lower carbon intensity. This is what we ran through already. So we all saw that location shifting part with the rainforest things and everything there. And then using languages and technology stacks that optimize the efficiency of specific microservices function. So using building blocks that are good for the environment, essentially. Now, there's this energy efficiency across programming language. Has anyone seen this before? Yes, I see, and I see someone laughing as well. This went quite viral semi-recently, a while ago. So this kind of like works around the internet quite often. Now, it is a nice and very valid study done by these fellows here. And it is very good, but obviously at the same time, one can always remember that if you, for example, because a lot of this stuff is optimization, utilization, and actually managing your things very well. So I wouldn't necessarily, like if you are really good with using Ruby, Python, Perl, somewhere in the middle, you probably write better sustainable code if you write it well and you write it in a very optimized and well-utilized way than if you did really, really bad code with Rust and whatnot. So there's no need to kind of now be, switching languages completely if you think that, oh no, I'm on the bottom there. No, not at all. because it's more about what you do with that language. But it is a nice comparison, though, on different things as well. And I think also an interesting thing to note there is that so that was the energy output, but then the next one there is then the memory and the data output there, so like how much memory is needed, and that list looks not completely different. Or for example, Python goes from the bottom there with Ruby to much more higher there. So it's not a zero kind of sum game there either. So, but something that tools we can use to manage things. So then we have optimizing your database as well. So choosing your database well is the first one. Maybe a bit of a easy one, kind of just think about your solutions. So ensuring that you have best database for interacting with your data set as well, and then using an index as well if your database offers it. Evaluating and optimizing your queries as well, and using a database cache there as well. So in some cases, caching can reduce redundant queries in the database and decrease energy used by the database and everything. So then we have understanding latency limits. We're going to get the demo soon, don't worry. So think about what you actually need from your application. So quite often, I think in the tech industry, people might think that, oh, this service needs to be the most performance optimized, it needs to be the fastest, it needs to be the fastest overall constantly. And for some cases, obviously, very relevant, like very, very relevant. But there are cases where it doesn't need to be maybe the fastest out there. Maybe it needs to be just, it's okay that it's a bit slower. And by slower, I mean it doesn't have to be like slower that it impacts the user experience, but something that doesn't have to be immediately available. Or like that magazine page, did we really lose a lot of value by the image being in grayscale? Not really. So, you know, you can think about these kind of things, and does something need to be the fastest out there constantly? Mentioning the request and response cycle as well is good, which is separating certain operations outside of this. So, for example, if the request is to send an email that blocks that response until the email is sent, you can instead asynchronously send the email using a worker process and unblock the response as well. So using worker processes versus web processes, because worker processes have a lower priority than web processes. So the prioritization allows the worker process to run only when compute resources are not needed there. So again, using and running those worker processes in a region with lower carbon intensity, another point that we already discussed. And then we have delaying worker processes to run when the carbon intensity is at the lowest. So again, this was the time shaping as well. So these are like the same building blocks from the principal ones apply to every essentially pattern or best practice that you can find eventually. So when you know the principles, you can usually kind of work around the best practice pattern as well. So there's a lot of different, yeah. Yeah. I don't have an exact yes or no answer to you fully. I do have a few solutions essentially later on that Kubernetes does a lot of those things. So in the industry, yes, essentially there is solutions that does that. For Azure itself, all functions and whatnot, don't have an exact answer. But Microsoft has released a API that you can plug into that tells you essentially the carbon awareness of what's happening inside your Azure. So I would imagine that you could, with a bit of work, do that. But I don't want to give like a, yes, it's available and you can do it immediately. But I'm going to show later that Microsoft does have a dashboard where you can see the emissions that your Azure produces. And now they have released that API that you can then plug into. So essentially, like let's say that if it's not available right now, it will likely be available at some point. The space is constantly moving. happening. I think the API, the latest update on that was like a week ago. So constantly things are happening for sure. Yeah, but I'm talking about a few projects that's related to that quite soon. So yeah. So now I'm going to talk through a few CNCF or open source projects in general that you can kind of then actually use with your services right now already. So CNCF, how many here is familiar with CNCF? Before, okay, couple, 4, 3, so hands, perfect. So CNCF is the Cloud Native Computing Foundation, and it is home to Kubernetes essentially. So it is a foundation under the Linux Foundation. It's a non-profit, and it organizes events such as KubeCon and whatnot, and over 150 or so, I think 170 maybe nowadays, different open source projects that are under the umbrella of CNCF. So anything cloud native, CNCF helps. So in addition to kind of educating people with the events and certifications, the biggest part is supporting these open source projects and getting them up and running, and helping the maintainers by meeting that. So CNCF has a landscape document image, which is this. It's a lot if you see it for the first time. It's a lot if you see it for the second time. And I've seen it hundreds and hundreds of times, but it's way too much. Like, you can't just kind of like look at this and understand everything because it's so tiny as well. So you always have to take a bit of a more in-depth look into it, but there's a lot of things you can use from the CNCF to do a lot of things. Now, in the CNCF space, there is a 1-year-old-ish. Well, it was started on May 31st last year. So there's a working group for environmental sustainability there. So that is a group within CNCF that's working as an open source group, so everyone can join in. That is working on precisely on, okay, sustainability and Kubernetes. How do we get these things working together really well? They are doing a lot of work currently as well. They are, for example, building best practices, playbook or best practices patterns as well. It's work in progress document is out there, but it essentially has one pattern right now, and that's not vetted either. So this is one of these things where I can say that, hey, this is really cool. They're working hard. There's sometimes some things out there already, but more to follow in the coming months, definitely. And the space keeps kind of updating more and more. I have a bit more about their projects that are up and coming later. But now we're going to get to one project, which is autoscaling and KEDA, which is a demo, and that's exciting. More action here, not just me talking here endlessly. So KEDA is essentially this. So default Kubernetes scaling is not well suited for event-driven applications, and KEDA is event-driven scale controlling that can run inside any Kubernetes cluster, so it can monitor the rate of the events to preemptively act before a CPU is affected there. How many here has heard about KEDA before? The most people, I have like 4 or 5. Oh, perfect. KEDA is more famous than Green Software Foundation. that totally works. So you can install it to new or existing clusters, and it has 30 plus built-in scalars, and you can build your own. It has support for external scalars, external push and metrics API, and whatnot. So I have a demo, which is KEDA scaling .NET Core Worker with Azure Service Bus as well. And this is essentially here the architecture. So we have order portal, order processor, Azure Service Bus, order generator, and so forth. But we can just imagine essentially that this is a online shop, for example, place where you would get your back to school, shopping, your books, your pencil cases, and whatnot, and people want to buy a lot of things at the same time. So then we can hop on to, if I see my mouse, there we go. We can actually hop here for the demo. So then I have here is the order queue, which I've just gotten by doing this, so you can keep certificate services and using this external IP there, and there we do kubectl get deployments namespace KEDA.NET. Oh, that's a bit bad. Let's write that up. So we do that here. then we actually get a bit more visibility into here. So we see how many order processors we have ready. It is at 0 currently. That's the point of auto scaling. We're going to start scaling it up soon. And then to get even a bit more visibility into what is the status of our creation, we're going to do kubectl get pod here. And then we see the status there. So now the demo itself is going to be quite fast. And we're going to be doing this .NET run here. And then it's going to ask us, let's queue some orders. So these are the orders that process we would need to process. So how many do you want? I can ask you, can anyone give me a number between 100 and 150? Anyone? 130 or 150? Okay, that's a good choice. That's good. Let's go for the big number, 150. So we're going to queue 150 orders. There we go. So now the orders are going to come flying in. As I said, it's going to be fast. So we have the bacon, chips, computer, bike, shirt, soap, everything happening. And now we can see the order queue going up. We can see the order queue going up and up. So there's the 100 mark. So we're going to reach that quite soon. It should be going up to 150. Because that's what we selected there. And then we should see KEDA jumping into action soon as well. Azure has been having a bit of hiccups today, so let's fingers crossed that it's all going to be working. It was working earlier. Let's see. Repeat there. There's not that much happening, but do not worry. I do have a recording of the demo if it's not working adequately. Let's see. It's looking enough like it's looking a bit bad. Yeah. It was working an hour ago, so. Well, I will find that recording then. Let's get that working. Because we want to see that, don't we? Good thing I recorded it. Okay. So it's not going to be 150, unfortunately, this time. Let's see here. There we go. So, there we see. We have now the queuing is going to start. 90 this time, unfortunately, sorry, but we see the point here. So we have the orders coming in, so bacon, shirt, and everything exactly the same way that just happened. But then this time, actually, things should start picking up and working. Now you see, there we go. So we have order processors. There we have running, we have pending, we have the ready 4 out of 4 of them already, and we can see that it's peaking just below the 100. It would have been peaking at 150 for the 150 example. But we see that it's picking up a few more order processors, so we are at 80. We're at 8 out of 8 right now, and we are running and we're creating them. So we're auto-scaling automatically up, so that we are only using the resources that we need. So when queues, when orders come in, we are auto-scaling up, and then when the orders stop ending, we're no longer creating any more order processors. So we capped at 10 out of 10 and running there as well. So that's it. Essentially, we auto-scale to meet the demand, and then it's going to take a bit of time for it to start ending it down, but it should start here. So you see here, so then we auto-scale down, which is obviously very important as well. You can't just meet the demand and stay at the high level. You have to also auto-scale down to not use those resources. Good thing I recorded it. I literally recorded it like 1 hour before the session. I was like, nah, Azure should be working, but good thing there. But yeah, so that was a quick KEDA demo there. So there's a lot of different services that you can use as well to kind of manage these things and help with. So there's Service Mesh, for example, because it's very fast. It's ultra light, ultra fast, security first service mesh for Kubernetes. It's Linkerd. And the overall goal of Linkerd itself is to reduce the mental overhead of having a service mesh. How many here has heard or used Linkerd before? 4 or 5 people. Yes. and it provides observability, reliability, and security. So, for example, the observability part is very important when you're building green software and thinking about sustainability angle, because again, you need to know what's happening inside your environments and clusters. So Linkerd has a private open source community. It has a simple minimalist design, deep runtime diagnostics, so including automatic service dependency maps and live traffic samples. It's built in Rust and it's fast, and the data plane proxies are small and fast. It installs in seconds with zero configuration, and it has actionable service metrics such as success rate, request volume, and latency for every service. Now, there's policy management as well. So you have Kubernetes, which is designed for Kubernetes itself. It's another CNCF project. It is not, again, specific to green software project, but if you need to have policies around your sustainable portions of your software, Kubernetes is a great option for managing policies there. So you can manage just Kubernetes resources, so you can use kubectl, Git, and customize. You can use a lot of these things as well. And then a project that's specific within the Kubernetes space to sustainability, which is GreenCube. So that is it's focused on spinning down deployments, reducing the number of replicas to zero, essentially, during hours when they are not being used at all. So essentially, kind of auto-scaling, but a bit of a different take on it than KEDA as well. So for example, during the night, during the weekends and whatnot, when you're not using, for example, your dev or preview pods, for example. So KubeGreen is a simple Kubernetes add-on that automatically shuts down some of your resources when you don't actually need them. How many here has heard about GreenCube? Okay, great. And GreenCube also has a calculator on their site, so how many CO2 is produced by your pod. And I think I should have that open here as well. Yeah, so here you can easily just go here and put more, for example, total number of pods, whatnot, and it's going to give you immediately answers there. So there's a lot of resources that you can find with that as well. And also, if you are using a GitHub solution, for example, or Argo CD, they, for example, have an article out on how to use KubeGreen with Argo CD, because the basic fundamental principle of GitHub, for example, collides with using GreenCube, but there are ways to kind of combat that. So there's a lot of resources around that topic as well. And there's so many different projects in this space that you can, again, follow up on later as well. So there's Kepler, which is using ePPF to probe energy-related system stats and exports as Prometheus metrics. They had a recent lightning talk in GitOpsCon, for example, that showcases these things. There's carbon-aware scaling, so POC, which is aiming to integrate CO2 emission intensity data into KEDA scaling decisions, so that when we get KEDA into the mix with the environmental projects as well. And then there is the carbon-aware SDK from Green Software Foundation as well, and that kind of takes into account all of the time shifting and location shifting, so you can build tools that are carbon-aware by using the carbon-aware SDK, again, from the Green Software Foundation. So there's so many things happening. And I think a good reminder is like all of these environmental solutions, which are like tailor-made, purpose-built for helping with sustainability issues. So obviously those are really great. But you can also use best practices from other fields creatively as they fit. So when I started speaking about these things like sustainability and Kubernetes a few years ago, there was some sustainability materials around, but not that many, to be honest. So then, for example, the best tips to use were cost optimization tips. So like if you optimize for cost, for example, you end up usually optimizing for sustainability as well. So it's definitely not that, you have to follow only green principles if there isn't, for example, information out there for what you're doing. If you're just using general optimization tips or cost optimization tips, for example, you're going to get quite close. And quick tips to just kind of get started if you're like, oh my god, there's so much info, so many things to try. Focus on observability, like understand what's happening in your clusters and your environments. Then focusing on the optimization, for example, on those little cost optimization, things that usually end up with the green optimization as well. And then governance as well. So for example, using policies and making sure that sustainability goals are related to cloud services and resources and so forth. So you can start with like basics as well. And as mentioned kind of before, the benefits, when you do green, sustainable Kubernetes and environments, you end up usually having a lot of organizational improvements as well. And you usually end up having improved performance as well, because when you are kind of leaner and meaner and optimized, you usually also serve your users better in that way. You end up with cost savings quite often as well. And obviously, sustainability goals should be a self-serving goal on its own, but obviously for organizations, it is nice to have all of the other benefits as well. And I think the big benefit, saving the world, we all want to save the world. We want to be like this hero back there. So it's going to be nice. Starting to kind of wrap up, and when we're going to go to resources. So we went through introduction, we went through the principles of green software, we went through the principles in practice, and then CNCF, an open source project in this space as well. And then we have slides and materials. It's all going to be in my GitHub from there. There already is the slide deck from Sydney, but I've updated the slide deck, so I'm going to add it today, later on there. And then there's the collection of links from all different places, but again, you can use the GitHub link to find these links, but there's so many. So you have anywhere from Green Software Foundation, they have a lot of videos, they have a podcast that has a weekly wrap-up of an hour of green sustainability news and everything. And a lot of upcoming projects as well. And the CNCF Environmental Sustainability Tag is also working on a lot of things. They did in the last KubeCon in Detroit, they did how to get involved with the sustainability tag session as well. That's on YouTube. So if you want to kind of get started, get contributing, get involved there. They also have a really good Slack channel where if you just ask, hey, I'm trying to do X around sustainability and Kubernetes, there's usually going to be someone who's going to be typing an answer for you and answering all of your issues and whatnot. So that's really great as well, in addition to kind of building together these things. They have a GitHub page as well, where they have all of their issues and projects that they are working on, and they are building. One of the things that's there in the progress report there is the best practices, like a comprehensive best practice list for Kubernetes plus sustainability. But as said, very much a work in progress. They'll check back on a few months to see how it's progressing essentially. And I mentioned before that all of the cloud providers, here's an example from Microsoft, so you can use their dashboard to get these kind of visibility into like, okay, how much carbon is using here and there. And then you have, specific to this event, Microsoft has a Learn and Earn Swag Cloud Skills Challenge that they asked me to showcase to you. And if you follow that link, you're going to have there's going to be sustainability track that you can kind of focus on and do a cloud skill challenge there. A lot of other resources that I've mentioned, so this lightning talk here is the CI/CD, essentially using Kepler and Flux to get ops in a sustainable way. Then if you're using Argo CD, you can use KubeGreen with it, and there's a link there. Green Software has written an article on carbon aware Kubernetes. It's quite short, but it's still relevant. And the patterns that are showcased at one point, you can find them from the link. And I think the conclusion is any activity that you can do to optimize anything towards the better goal, your kind of goal. There's no need to stress about being perfect. You can kind of take a step and move forward there. But yeah, thank you from my side, and I hope you had a good time in the session.